All right, we're going to continue with our 7-2 notes videos. This is page 7. We're going to do some more factoring and solving here, just with a little bit of a different form. So let me zoom in just one more. There we go. So our example here, x to the 4th plus x squared minus 72. So this looks similar to what we did, at least in part, in the last notes video and a lot of Unit 4 when we learned about factoring. However, the exponents have changed just a little bit. But whenever we have an exponent whose middle term has a power half that, and whose final term is a constant, kind of just like we're seeing in this form up here, we still want to factor it using our guess and check method, okay? So this is equal to 0. We don't have to worry about that. We're going to go right to step 1, being factoring this trinomial into two binomials, okay? So as if this were an x squared and x in a number, when we set up our two sets of parentheses, it would be an x and an x here, or some version of x and x. Well, we know that these two numbers have to multiply to be x to the 4th, so now we should have x squareds as the first terms in our two binomials. Why? Because x squared times x squared would give us x to the 4th, so we know that's got to be right. And now they could have a coefficient as well. If this were a 2x to the 4th, we'd have 2x squared and x squared, but it's not. And then just like our factoring and all that work we did back in Unit 4, we're looking for two numbers that multiply to be negative 72 to go here and here. So we have lots of options. We have 36 and 2, 72 and 1. The ones that are going to work here, and maybe noticing that this is a very small number, in fact a 1x squared, would lead us maybe to choosing 8 and 9 as our options. Okay. Since this is positive, I'm going to make the larger number here positive. So I'm going to go x squared plus 9. I'm going to go x squared minus 8. All right, now that's still equal to 0. So we have completed our first step of factoring this quadratic into two binomials. Our next step, we're going to use the zero product property to set these equal to 0. Well, here goes the first factor equal to 0. Here goes our second factor equal to 0. And now we get to solve. Okay, we're going to use our inverse operations. Remember, when there's no middle term, quote unquote, or another term that just has an x. So we have an x squared and a number. All that's left is to get the numbers on one side, the x squareds on the other. So subtracting 9 from this, adding 8 to the other. And then we want to solve for x. Right now we have an x squared. We're going to take the square root of both sides. Here, that's going to lead us to no solutions that come from this factor, this equation, because we know we can't take the square root of a negative number. This will give us two solutions. Why 2? Well, we have to remember that when we take the square root in an equation, we always come up with a positive or negative as our answer, or as our result. We also should make sure that we can simplify this radical, since it's something we did in an earlier topic of Algebra 2. So this would split to root 4 and root 2. The square root of 4 is 2. And those would be our two solutions here. Okay. Now, one of the things that we can talk about is like how many solutions could or should there be. If the highest exponent you see on the variable is a 4, that means there could be up to 4 solutions. Now, this equation, okay, gave us solutions that weren't real. In fact, these would be imaginary solutions. We don't deal with that in our Algebra 2 class. So in actuality, we would say that there are no real solutions that come from this. So we're kind of missing 2, and then we have our 2 solutions here. So those are things you can kind of think about as we're going through this. But hopefully a little refresher of our factoring and that slight adjustment that we make. The fact that this is an x to the 4th caused our first terms here to be x squareds, but all the rest of it is a lot of things we've done, learned, even simplifying the radical we've done in the past. So let's move along to some individual practice using that guided example as a model. As always, check in with your teacher to make sure this goes well before moving on.